Hey guys, welcome to Crown Smart. In today's class, we'll be talking of differentiating the following exponential functions. And you know, we have various ways of differentiating exponential function. First of all, what is an exponential function? Now, observe here, you have e. We have here as e and we have here as x. Now, this is f of x equal to, that is function of x is equal to the base is this base here e is a constant. Okay, it's a value, a known value e, the Euler's number, and x is just a variable. So whenever you have a constant raised to the power of an unknown variable, then that is what an exponential function or exponential function. Now, to solve this, to differentiate an exponential function, we just use three steps. This is just a short way of differentiating exponential function, other than using chain. It's still part of chain rule, but it's a short way of differentiating exponential function. So, to solve this, the first, let's say we're taking f of x to be exponential x. Now, to solve this, that is f prime of x, is just three steps. And the first thing you do is to bring down the function. The first thing is to do is to write the function back again. Now, this function will multiply another 10 again, and that is the ln of the base. You take the ln of the base. Okay, after taking the ln of the base, you still multiply them, and the last step you still multiply it. The last step is now you now differentiate the function, that is, you differentiate the power. This is where the power becomes the what? The variable. Okay, a function of x. So you differentiate the power. You have when you differentiate x, you have 1. Okay, so our final answer is exponential x. Now ln e is what? Is 1. Now 1 times 1 is already 1, so we have that our f prime of x is exponential x. That's how we differentiate this. Now this, for the second one, we have g of x equal to exponential 2x. Now to differentiate this, as usual, g prime of x is equal to, what's the first thing you do? You write back that same function, then you multiply it, take the ln of what? The base, and then differentiate the power. If you differentiate 2x, what do you have? 2. Now ln e is always 1, so 2 times 1 is 2, times this is equal to 2 exponential 2x. So this is just a 3-step way of differentiating exponential function. So we'll go for number 3, that says h of x equal to 5 raised to the power of 2x. We're doing the first two examples, and we had e there. So this is a different one that involves 5. You can also have a function, maybe you can have 3, 5x squared, doesn't matter, so far as the base is a constant and the power function of that function of x then is an exponential function. Now in the same manner, we solve this as h prime of x to be, we write down the function. That's the first thing we do. Secondly, we take the ln of 5, and lastly we differentiate the power, and we have 2. So this is actually your answer. Ln 5 is a constant, it's a value. If you press the calculator, it will give you a value. So this is actually the answer for h prime of x. Now another interesting one is the fourth one, where we have this function of x to be e raised to the power of sine x. Now to solve this, we use the same method. The first thing you do is write back the same function. Secondly, take the ln of the base, which is ln e, and lastly differentiate the power. Now the power here is sine x. Recall, if you differentiate sine x, you have what? Cos x. So we write cos x. So and we know that ln e is already 1, so this is equal to cos x exponential sine x. So that's your answer, and that's how you solve these problems. I hope you understand this. Please do not forget to subscribe. God bless you.